Okay guys, so this week we're going to have 2 videos and worksheets to go along with them, and then you guys are going to kind of have an easy day on Thursday. Okay, so for this video we have solving trigonomic equations with identities. So we're going to go over these identities. There's a lot, okay, so feel free to pause the video to help yourself while you're working. Okay, so we are given the Pythagorean identities, okay? There's 3 of them. Remember, this is the one we were given, and we can manipulate it and change it to rearrange to give us 2 more. Okay, then we're given the even and odd identities, which we've learned before, okay? So this is just kind of like a review right now, okay? So the even and odd, so remember cosine and secant are the only ones that have the even, okay? And the odd ones are sine, its reciprocal, and tangent and its reciprocal, okay? So then we move to the reciprocal identities. So we have sine, cosine, and tangent, which is just 1 over, we have 1 over cosecant, 1 over secant, 1 over cotangent, and then if you find the reciprocals, right, it's just the opposite, okay? And then last but not least, we have quotient identities. So we have just meaning dealing with division. So we have tangent, which is sine over cosine, and cotangent, which is the opposite, is cosine over sine. Okay? So remember, you can pause the video at any time so you can go back, write these down if you need to, or you can pause the video to have it there while you're working. Okay, so the first thing we need to do is verify that tangent time, and this is theta, okay, which is the same thing before we had like tangent of t. This variable right here, we're using a Greek letter, theta, to represent a measurement, right, of an angle, whether it's in radians or degrees. So we have tan and times cosine is equal to sine. So we need to prove that, verify. Okay, so we know that tangent is sine theta over cosine theta, right? And then if we multiply that by cosine, right, which is like over 1, we can cross multiply these out. Okay, so this was there, that is there. We can cross multiply, cancel those out. So then we just have sine theta left over, which is equal to sine of theta. So we have verified it. Okay? The next one, we need to verify that 1 plus sine theta times 1 plus sine of negative theta, okay, is equal to cosine squared of theta. So the first thing we need to know, this is one of our even and odd identities. So remember that sine of negative theta, okay, let me just write this down. So we have sine theta, and then we're going to be having 1. And then sine of negative theta, if we look back, sine of negative theta is equal to negative sine of theta. So we just replace the whole thing with negative sine of theta. Okay? Now if I were to FOIL, okay, so FOIL, first, outer, inner, last. So we do 1 times 1, right, which is 1. 1 times negative sine, so we have negative sine theta times 1, which is positive sine theta. And then we have sine theta times the negative sine of theta, so we have negative sine squared of theta, okay? And we're verifying it to equal cosine squared. Okay, so I have 1 minus sine plus sine, so these are going to cancel out because a negative and a positive cancel out. So we have 1 minus sine squared of theta is equal to, does that equal cosine? Right, this is what we're checking. Does it equal cosine theta, squared theta? Right, so if I look back at the Pythagorean identities, so we have this. So if I look at this one, if I subtract sine over here, I would get cosine squared theta is equal to 1 minus sine squared theta. So 1 minus sine squared theta is also equal to cosine squared theta. So they do equal each other. Okay, this is the Pythagorean theorem. Okay. Next one, we need to verify that secant squared of theta minus 1 is over secant squared of theta is equal to sine squared of theta. Okay? So I know, according to Pythagorean theorem, I can look back. Secant squared of theta, which is over here, and we subtract 1. So if I subtract the 1 over here, this whole term right here is going to be equal to tan squared of theta. Okay, according to this right here. So if I subtract the 1 over here, tan squared of theta is equal to secant squared of theta minus 1. Okay, the next thing I know, I'm going to keep this over secant squared of theta for now. Okay? So, remember that using reciprocals, okay, I could rewrite that as tan squared of theta over, and then remember that this would be, let's see, scratch that, okay? So we have tan squared of theta, and if we multiply that by 1 over secant squared of theta, right? We know that 1 over secant, let's see, where'd it go? 1 over secant is cosine, okay? So we know that this would become tan squared theta times the cosine squared theta is equal to sine squared theta. That's what we're trying to prove. Sorry, you guys couldn't see that. Okay, so I know that tan, remember, was sine theta over cosine theta. Okay, but we can just add in the squares. Okay, we need to verify that this is equal to. Okay, so if I cross multiply, I'm left with sine squared over 1. So sine squared theta is equal to sine squared theta. So this has been verified. Okay, just a couple more. So number 4, we need to create an identity for 2 times tangent of theta times secant of theta by rewriting in terms of sine only. Okay, so we have 2 tan theta times secant of theta. Okay, we need to write in terms of sine. So I'm going to rewrite this as 2, and then I know that tangent, right? Tan is sine over cosine, and that's theta. And then I know that secant is 1 over cosine of theta. Okay, so when I multiply these all across, I get 2 and then sine theta, right? Sine times 1. And then cosine, and cosine gets you cosine squared theta. Okay? So, what could I do? I need to write in terms of sine, they said. So I have 2 sine theta, right? And then cosine squared. So cosine squared, the only time I see cosine squared is in my Pythagorean identity. Cosine, if I solve for cosine, I'm just subtract sine. So cosine would be equal to, so if we have cosine squared theta plus sine squared theta equal to 1. I'm solving for cosine, so I subtract sine. So cosine squared theta is equal to 1 minus sine squared theta. So where cosine is, I can just write this. So 1 minus sine squared theta. Okay, they said to rewrite in terms of sine only. I have sine and sine. That's the only term I have. So another way to write tan, 2 tan of secant, okay, would be this right here in terms of sine only. So you can manipulate different types of identities, okay? You can create new ones and new ones and new ones and new ones over and over again. But we just had to do sine here. Okay, these are easy now. So we have, right, 2 cosine squared theta plus cosine theta minus 1 as an algebraic expression. So like, if I know that cosine, right, of theta is equal to x, right, our x coordinate, I could write this as 2x squared plus x minus 1. Okay, and that's all they wanted. Okay, an algebraic expression is ax squared plus bx plus c. That's the standard form. Okay, so this is all they want right there. If I make x equal to that, I can replace it. Okay? Last but not least, they want us to rewrite 4 cosine squared of theta minus 1. Okay, so I can change this to be 2 of cosine theta squared minus 1, right? Okay, and if I know that I have, let's see, I have this squared and this minus 1. When we're dealing with, you know, the difference of squares, this would be x is equal to x plus 1, right, and x minus 1. So we're going to make it look like that if I had a difference of square. So then I have 2 cosine theta plus 1, and then 2 cosine theta minus 1. Okay, I just broke it apart. Now you guys can see that better. Okay? So I have 4 cosine, I break it up, right? I take the square out. And then I am using difference of square knowledge to break it apart even further. And that would be your answer.